You've maybe heard the term atoms and elements before, and a lot of people think that these terms are interchangeable, but that's not the case. They are related to each other, but they have different and specific meanings that you need to be aware of. So let's first take a look at what an element is. An element is a substance that cannot be broken down into simpler substances by ordinary chemical means. So what this means is that we can't take an element and take it into a chemistry lab and by doing some chemical reactions turn it into something else. There are ways, especially in physics, where they have technology now where they can change an element or an atom from one type of element to another type of element, but that's not typical, and you need some very specialized equipment in order to do that. So now, how are atoms related to elements? So an atom is just the smallest particle of an element that displays all of the properties of the element. And when we are referring to properties, so different elements have different properties in the sense that they differ in their density, their solubility, their melting point, and their reactivity. So you can think of an atom as being the smallest piece of an element that can exist. So for example, let's take a look at the element known as carbon. So carbon is an element that has certain properties. And you can have one atom of carbon, and that is the smallest piece of carbon that can exist and still have all of those properties of the element carbon. Atoms are made up of three subatomic particles. These three particles are known as protons, neutrons, and electrons. Protons are positively charged, and they are located in the nucleus of an atom. And the nucleus is just the center of the atom. Neutrons are neutral, meaning that they don't have a charge. And they are also located in the nucleus or the center of the atom. Electrons are negatively charged, and they are located in these areas that are actually orbiting or surrounding the nucleus. And we call these areas, we call them either orbitals, shells, or clouds. So they are located in orbitals, or sometimes we call them shells or clouds surrounding the nucleus. Another important factors of these subatomic particles is their mass. So protons have a mass equal to 1 AMU. And AMU stands for atomic mass unit. Neutrons also have a mass of 1 AMU. But electrons have a mass that is negligible. So we essentially consider it as 0. So the mass is 0 atomic mass units. Another key thing that you should know about protons and electrons specifically is that protons determine what the element is. So the number of protons determines the element. If you were to change the number of protons in an atom, you would actually change the type of element it is, and therefore you would change the properties of that element or of that atom. Electrons determine whether an atom is going to be able to form a chemical bond with another atom. So we can say electrons are the subatomic particles involved in chemical bonding. It may be helpful to make a chart like this in your notes in order to help you keep track of the similarities and differences between these subatomic particles. So remember, we have our protons, which have a positive charge, and they are located in the nucleus of the atom. And their mass is equal to 1 atomic mass unit. Neutrons are neutral, so they have no charge. They are also located in the nucleus of the atom, and they also have a mass of 1 atomic mass unit. Electrons have a negative charge, and they are located in the orbitals, which we also call shells, or the cloud, surrounding the nucleus, and their mass is 0 atomic mass units. You've maybe seen a picture similar to this before. So what you're looking at here is the periodic table of elements. So this is a reference tool that lists all of the known elements. And this tool is really helpful because it's going to tell us a lot about these individual elements without us having to memorize all of it. So we can kind of take a look at hydrogen up here. And you can see down here that we also have hydrogen kind of zoomed in so that we can see it better. And we can see that these individual squares tell us a little bit about hydrogen. So first of all, we have the atomic number. And that atomic number is going to tell us how many protons are in an atom of hydrogen. So hydrogen has 1 proton. The atomic mass number tells us the number of protons plus the number of neutrons that is in an atom of hydrogen. On the next page, we'll talk about why these numbers are important and how we can use them to better understand the properties of these elements and how they form bonds with each other. Some additional elements that we are going to focus on a lot in this course are going to be carbon, nitrogen, oxygen, sodium, calcium, chlorine, and potassium. And the reason why we are going to focus on these in this course is because these are elements that are extremely vital to life. Now, living things do need other elements, but these are some of the main ones that are involved in things like human anatomy and physiology. So we're going to start out by looking at the elements carbon, nitrogen, and oxygen. And so I took a kind of a picture of just these elements from the periodic table. So first of all, we're going to look at the atomic number. And the atomic number is the one that we can see in the upper left-hand corner here. And the atomic number is equal to the number of protons in an atom of that element. So if we're trying to figure out the number of protons in each of these elements, we can easily find that by looking at the atomic number. And remember that protons are positively charged, so I like to write a little plus sign to remind myself of that. So carbon has an atomic number of 6, so carbon has 6 protons. Nitrogen has an atomic number of 7, so nitrogen has 7 protons. Oxygen has an atomic number of 8, which means that oxygen has 8 protons. Now, the other number that we see is the atomic mass number. And for the sake of this course, we're actually going to round this number off. So round it up or down based on what the decimal places tell you. Now, this decimal place is important. It refers to kind of the ratio of the different isotopes that exist for each of these elements. And we'll talk about what an isotope is a little bit later, but for now, let's just focus on rounding it off and taking a look at the most common isotope. So for carbon, we're going to say that the atomic mass number is 12. For nitrogen, the atomic mass number is 14. And for oxygen, the atomic mass number is 16. And the atomic mass number is just equal to the number of protons plus the number of neutrons. So if we wanted to find out how many neutrons there were in an atom, we could easily just take the atomic mass number minus the number of protons in order to get the number of neutrons. So we can take the atomic mass number minus the number of protons to get the number of neutrons. So for carbon, we can take the atomic mass number of 12, subtract the number of protons, which is the same thing as saying the atomic number, so 12 minus 6, and our answer is carbon has 6 neutrons. For nitrogen, we can take the atomic mass number of 14, subtract 7, which is the atomic number, which tells us the number of protons, and our answer is going to be that nitrogen has 7 neutrons. For oxygen, we can take the atomic mass number of 16, subtract 8, which is the number of protons, and we get an answer that oxygen has 8 neutrons. So just to recap, remember that the first number in this equation, this is the atomic mass number. The second number is the atomic number, which is also saying the number of protons. And then the answer is the number of neutrons present. Now, you'll notice that we have one more subatomic particle, the electron, that we haven't really talked about yet, and we're out of numbers. But it's actually fairly easy to figure out how many electrons are in a neutral atom because it's going to be equal to the number of protons. Because remember, electrons are negatively charged and protons are positively charged. And all atoms pretty much start out neutral. Now they may gain or lose an electron, and we'll talk about when that happens when we talk about ionic bonding and ions. But for now, let's just say that the number of electrons is going to be equal to the number of protons. And remember that electrons are negatively charged, so I like to put a little negative to remind myself of that. And so the charges cancel each other out. So for example, an atom of carbon has 6 positively charged protons and it's going to have 6 negatively charged electrons. Nitrogen is also going to have 7 electrons because it has 7 positively charged protons. And oxygen is going to have 8 negatively charged electrons because it has 8 positively charged protons. So to get the number of electrons, you just have to look at the number of protons, which remember is also based on the atomic number. So now let's take a look at sodium and potassium. And I recommend that you pause the video right now and try to work these out on your own. So try to figure out what number is the atomic number, what number is the atomic mass number, and then figure out how many protons, neutrons, and electrons each of these elements has. All right, so hopefully you paused the video and tried this on your own just to see if you understood this concept. But now we're going to go over it just in case so you can double check your work, or if you still just don't understand this concept, here's another example to help you hopefully better understand it. So first of all, remember that this number here is the atomic number. And the other number is going to be the atomic mass number. And remember, we're going to round these numbers off. So for sodium, we're going to say that the atomic mass number is actually 23. And for potassium, we're going to say that the atomic mass number is 39. So for sodium has 11 positively charged protons. And remember that we got that number from the atomic number. Potassium has 19 positively charged protons. And once again, we got that from the atomic number of potassium. Sodium, to find out the number of neutrons it has, we're going to take the atomic mass number, which is 23. We're going to subtract the number of protons, which is based on the atomic number, and the answer we're going to get is 12. So sodium has 12 neutrons. For potassium, we're going to take the atomic mass number of 39, subtract the number of protons, which is the same thing as saying that you're subtracting the atomic number. So subtracting the number 19, and we get an answer of 20. So potassium has 20 neutrons. Now to figure out the electrons, the number of electrons is just going to be equal to the number of protons. So sodium has 11 protons, so it's also going to have 11 electrons. Potassium has 19 protons, so it's also going to have 19 negatively charged electrons. So now that we know how to figure out the number of protons, neutrons, and electrons that are in an atom of an element, let's draw a model of kind of what these atoms look like. Now, atoms are so small that they are submicroscopic, meaning we do not have the technology to actually see what an atom looks like, but we have models of atoms that we can draw to help us visualize. And these models have been developed based on the way that atoms act. And honestly, someone smarter than me that knew physics and chemistry better than me came up with these models. But here's how we would draw kind of a sample model. And being able to draw these models are going to help us be able to figure out how atoms form bonds with other atoms in order to form molecules. So first of all, remember that we said that protons and neutrons are both located in the nucleus of an atom. So let's start by drawing the nucleus. So in the nucleus, we're going to have our 6 protons, and I typically just draw that or write that as 6p+. And also in the nucleus, we are going to have our neutrons. So I just write that as 6n. And you can maybe draw like a dotted line or something around this to just kind of help you remember that this is the nucleus. Now remember that the electrons exist in these orbitals, which we also call shells or the cloud. And these orbitals are orbiting or surrounding the nucleus. And so we can draw an orbital as just a line or an orbit surrounding that nucleus. Now we have 6 electrons, and it's possible to actually have more than one orbital. And for carbon, we actually have to have more than one orbital because the first orbital can actually only hold 2 electrons. So we can draw those 2 electrons in there by just drawing little circles. Now, carbon has 6 electrons, but the first orbital fills up with 2. So we have to draw another orbital. Now the second orbital can hold up to 8 electrons. So we've got 4 electrons left, so we can put our remaining 4 electrons in this second orbital. So now we have our 6 electrons placed. So we've got the first and the second ones in the first orbital, and then numbers 3, 4, 5, and 6 in the second orbital. So that first orbital, or first shell, can hold a max of 2 electrons. The second shell can hold a max of 8 electrons. So looking at this, you can kind of see a simple way to draw one atom of carbon. So now let's try drawing another model, this time looking at the element hydrogen. So looking at an element, or looking at an atom of hydrogen, we have 1 proton that goes in the nucleus. Now, hydrogen typically does not have a neutron, so we actually don't have to draw the neutron in there at all. And I'll put a little dotted line to remind myself that this is the nucleus. Now, we have to place the 1 electron that hydrogen has into an orbital. So we draw 1 orbital around the nucleus, and we put our 1 electron in that orbital. And we are done. So this is what a model of hydrogen would look like. So hydrogen is a very simple element with 1 proton and 1 electron. Let's do another example, this time looking at an atom of the element sodium. So sodium has 11 positively charged protons in its nucleus. It has 12 neutrons. And I'll put my little dotted line so I know that this is my nucleus. And then it has 11 electrons. So we're going to start by drawing our first orbital. And remember, the first orbital can only hold a maximum of 2 electrons. So we'll put our 2 electrons in that orbital. But we still have 9 electrons that need somewhere to go because we had 11, we placed 2 of them, so we still have 9 electrons that need somewhere to go. So we can add a second orbital. Now remember, the second orbital maxes out at 8 electrons. So we can draw 1, 2, 3, 4, 5, 6, 7, 8. So now we've taken the 9 electrons we had left, we got rid of 8 of them, but we still have 1 electron that needs a place to go. So what do you think we're going to do? We're just going to add another orbital. And this orbital is only going to hold 1 electron. So once again, we want to go back and double check and make sure all of our electrons are where they should be. So we've got electron number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have all 11 of our electrons placed in our orbitals. Now, do you think we could add a fourth orbital if we were looking at an even bigger atom? The answer is yes. We can just keep adding orbitals. And the only restriction is that the first orbital, remember, has a max of 2 electrons, but every orbital after that first one can hold a maximum of 8. So orbital number 2 can hold a max of 8. Number 3 can hold a max of 8 electrons. If we added a fourth one, it would also max out at 8 electrons. If you want to practice more of these skills, I recommend that you do so on the following elements. With models, we've already looked at carbon, hydrogen, and sodium. You can also draw some models for things like oxygen, nitrogen, chlorine, calcium, potassium, and really any element that's on the periodic table, you could draw a model in the same way that I have shown you how to do this. But these are some good ones to practice on, so give yourself some practice and see if you understand this concept.